Good evening. Welcome back to Freeburg's math class. We're going to take a look at the review unit number 4. We're looking at congruent triangles. Going with the theme of food for the top here. We got some pizza to follow up our flapjacks, pancakes we had the other week. But we're going to go through this. I'm probably going to go way too fast as usual, but beauty of this being on record is you can hit pause, try the problem yourself, watch how I do it, kind of in fast forwarded mode almost, and then give it a shot yourself. So as you're taking this, again, make sure you're hitting submit after every few problems. I'd hate for you to lose your progress. The only way for it to save is by hitting submit. And this is the video that's attached to help you through it. So classifying our triangles is the first thing we're going to take a look at. So classify each triangle by its angles and sides. So if we're looking at A there, the triangle we're looking at is ABE, which you'll see is ABE. That's that right triangle there. And it's got a side length of 7, looks like, side length of 7, and a right angle, and looks like a much shorter side length. There's no markings to indicate these are identical or not, so we'll assume that all three of those are separate lengths. That would tell us that it's scalene based on its side lengths, and then because of that right angle, we know that this is a right triangle as well. So we would go ahead and select those options, scalene and right. There we go. Yeah, right and scalene. So let's take a look at the second one there, BEC. We'll have triangle BEC, looks like BEC, that's the one that's kind of flipped upside down. It's got another split off piece there that is congruent. This is actually important, and I'll tell you why here in just a second. This has a measurement of 2 from F to C. And E, this again has that side length of 7. So since ED down here is measurement of 5, and this is an equilateral triangle, this must be a side length of 5. 5 plus 2 is 7. So that actually tells us that BE and CE are both 7. So this will actually give us an isosceles triangle. Isosceles. There we go, missed my E. Isosceles triangle, and all those angles look like they're less than 90. So this would also be acute isosceles triangle. Let's take a look at triangle DEF. DEF, that's one we just looked at, right? So this one obviously has 3 tick marks. This is going to be an equilateral. And it was also an acute. All those side lengths or all those angles are less than 90, because we know an equilateral, all those angles are 60 degrees. That's one of its special traits. So there's that. And lastly, triangle CDF. CDF looks like that. There's our 2. That we knew was 5. And so that angle up here looks greater than 90. And so this will be a scalene, because all 3 scalene. All 3 are different length, and this will be obtuse. Cool. All right, so hopefully that all makes sense. Use the check marks to check all that apply on those. Don't just do one. Make sure you get the classification by angles and classification by sides. The only one where you'd only check one is the equilateral. So, angles of triangles. So now we're going to take a look at the angles in here. We'll look at number 3. I am going to highly encourage you all to use a piece of paper. Just like I am kind of using a piece of paper. It's a digital piece of paper, but I am writing things down because this is a lot to try to keep in your head. And as much as I don't want to say that I can do math better than some of us, if I can't do it in my head, chances are neither can the rest of us, right? Like, that's a lot to keep in your head. It's 5 different angles that you're trying to find, not to mention the other angles that are given to you. And so just do yourself a favor, get a piece of paper, make some notes, and write some stuff down. So I'm going to start with number 1 there. That's a linear pair, so I know that 180 is equal to that 88 plus the measurement of angle 1. We'll subtract the 88 from both sides and see that 92 is equal to our measure of 1. Okay. Now that I have a measure of angle 1 there, what would I like to do next? It's a good question. Oh, I'm missing a piece of info. Those are parallel lines. That's important. So parallel lines tells us some important stuff. In this particular case, pretend those extend for forever. And pretend this is a transversal. Well, it is a transversal, but I'm going to highlight it for a moment. We'll see that our corresponding angles are congruent. So that tells us that the measurement of angle 3 based on corresponding angles of parallel lines, that measurement of angle 3 is 64 degrees. So that's actually super important. That's going to help me find angle 2. A couple different ways you can do it. You can either do the triangle sum here, or you can do your exterior angle theorem, whichever one you would prefer. If I'm doing the exterior angle, I'm looking for 22, right? But just for fun, let's go 92 plus 64 plus measure of angle 2 is equal to 180. Combine our like terms. This is 156. Did I say 22? It should be 24, which is what we're about to find out here as well. So again, I even made a mistake there trying to do it in my head quickly. So write things down, you make less mistakes. Measure angle 2 equals, subtract the 156 from both sides, and we get 24. So there's that. There's that. Oops. There we go. I'm going to go look at 4 now, because those 3 angles create a straight line. So I know that angle 3 plus 81 plus measurement of angle 4 is going to create a straight line, which we know adds up to 180. Combine our like terms, 145 plus measure angle 4 equals 180. Subtract that, so measure angle 4 is equal to 35. As much as I know this is repetitive stuff, write it down, because if you don't write it down, it's going to start to disappear on you. All right, so last one we're going to take a look at is, yeah, I'll probably do the triangle here. I'll do the triangle. And so we've got 35 plus 64 plus measure angle 5 is equal to our 180. Sorry, I ran out of room on that other side there, so I came back to the left. Combined like terms, it's what, 99? Plus measure angle 5 equals that 180, so we've got 81 left over when we subtract 99 from both sides. Boom! All right, so go ahead, type all those in, and you're in good shape. Number 4, very similar. Let's crank through that one as well. We've got a 90-degree angle, 61. That one fades out a little bit, and it does not connect to that right angle. There's angle 1, 83, 4, 115, 2, 5, 6, and 7. All right. So one of the things that jumps out at me right away, there we go, vertical angles. So I'm going to give you measurement of angle 4 first. The order of doing these does not necessarily matter, so just do whatever jumps out at you. These are linear pairs, so I'm going to do that one next. Measurement of angle 2 plus that 115 is equal to 180. So measurement of angle 2 must equal 65. Boom. And then guess what? Those are vertical angles, so measurement of angle 5 must also be 65. All right, cranking through some. That's good. We've got 2 at 65. We've got a triangle. So let's go find angle 1. Angle 1 plus 80 plus measure 2, which is 65, equal to 180. Combine our like terms, it's 145. Did that math on the last one also. So we know subtracting 145 from both sides will leave us with 35. So 1 is 35. Let's see, what else do we got? We have, let's see. I haven't really talked about this, so I'm hesitant to show it this way. Let's see, we know 4. Okay, let's do it this way. So what I'm highlighting right now is this purple. This is a quadrilateral, and we'll touch on this more later in the either this quarter or next quarter, I forget. But this is going to add up to 360. And so since I have 3 of the 4, we could add up the 3 and find 7 that way. I'm not going to show that though, just because that's not on the test. So let's go and look at this big triangle here. That's a right triangle. I've got a 90, I've got a 61, and I've got a measure of angle 3. That'll equal 180. Combine these into 151. Take the 151 away from both sides, we're left with 29. Okay. So now we've got 1, 2, 3, 4, 5. We need 6 and 7. So we've got 3 and 4. That'll help us find 6, and then we'll be able to get a linear pair. Perfect. Okay. So let's see. So 3, which is 29, plus 4, which is 115, plus 6, which is our unknown, is equal to 180. There's our triangle. What is this? Plus 30 essentially, so 144. Yep, 144. Plus measure angle 6 equals 180. Take it away. 36 left. Bam. Alright, so we've got that. And then we just need to finish with linear pair. So measure of 6 plus the measure of 7 makes a straight line. We know that's 180. Take it away. 144. Ah, we need that. That's an exterior angle theorem. We should have known that right away. Didn't even have to do the math. Woo! There we go. All right, you got 1 through 7 there. Type them in. Moving on. What's next? 5. We've got a triangle. This angle is 3x minus 1. This one is 6x minus 5. And this one is 8x minus 35. Alright, so those are all interior angles based on their arrows they drew for us. So we know that they're going to add up to, ding ding ding, 180. 8x minus 35 plus 6x minus 5 plus 3x minus 1 equals 180. 8 and 6 is 14, plus another 3 is 17x. Negative 35 minus 5 more is negative 40 minus 41. Add that 41 to both sides. We get a 221. Sure hoping that that's a multiple. What do you think? 13? That's my guess. Let's use the calculator. 221 divided by 17. 13. Hey, sometimes my mental math is right. Bam. All right, there's your x value. Going on number 6. Now we've got an exterior angle. Exterior is 11x minus 63. Interior 5x minus 11. Interior 2x plus 20. So we know our rule states that the sum of those two interior will equal the exterior. So 11x minus 63 is equal to 2x plus 20 plus 5x minus 11. Combine your like terms, 7x plus 9. Get our variables on the same side. So 4x minus 63. Add the 63. 4x equals 72. Divide by 4. 18. Bam. There you go. There's your x value. Okay, now we're on the isosceles and equilateral triangles, so we'll use some of our special properties. We know those are congruent, which means by our isosceles theorem, the base angles are congruent. So if that's 74, that's got to be 74. And if those are 74 apiece, that adds up to 148, which remains 32 up top. So we've got measure angle Q equals 32. Measure angle R equals 74. Hopefully that makes sense. Again, base angles are congruent. Add these up. We know it equals 180. All right, so I'm going to probably go through the rest of these a little bit faster, but that's kind of what I was doing in my head and making little quick notes on them. So number 10. Those are congruent. That's 106. Those have to be congruent because it's an isosceles triangle, which means 180 less that 106 is going to be 74. And then if we cut that in half, because there's two of them with the same measurement, this will be 37. 37 and 37. And that's what you're looking for, both measurement of E and the measurement of G, because they're the exact same, both 37. On to 11. 48 and 48. So if the base angles are congruent, that means the side lengths have to be congruent. That's our converse to the isosceles triangle theorem. So if this is 9, this has to be 9. Units are feet. And the angle measurement, let's see, 48 and 48 is 96. So take that away, 84 is your leftover piece. So we've got measurement angle A equals 84 and AC equals 9. Equilateral triangle, what are the measurements of all the interiors? They're the same. And so if you've got 3 of the same that add up to 180, divide by 3, each one's got to be 60. Boom. That's equal to M, N, and P. There you go. Alright, so those are your isosceles and equilaterals. That's pretty much the extent of what we'll look at as far as their special properties. So let's continue using those, but now we'll throw some variables in the mix. We've got isosceles here. There's 34. 80 or 8x minus 23 is one of these interiors. You know they're the same. I don't want to make more. Well, I don't know. Let's do more variables. That's fine. So both of those are 8x minus 23, right? Because they're congruent. So if I've got 8x minus 23 plus 8x minus 23 plus 34, we know that'll add up to the interior sum of a triangle of 180. 16x minus 43. That's this, 43. And positive 34 So is that minus 9? That's minus 9. Equals 180. So 16x equals 189. That doesn't seem right. What little error did I make? Minus 23. 34. Oh, 46. There it is. 46. So this would be 12. Get a 12. Let's make this into a 192. 192 divided by 16 is 12. So x equals 12. All right. Yeah, I'm not going to guarantee that all of these should be nice numbers, but most of them are. So if you get a weird number, at least kind of double check it. See if maybe you made a simple mistake. My simple mistake was here. 23 and 23 is 46. That was my error. So, okay. X equals 12. That's all we're looking for there. 14. This one, I'll use the other strategy I was thinking about doing on 13, but it's way easier over here, so why would I do anything other than that? I'm not going to take this and multiply by 3. That seems ridiculous. I know each of these angles is equal to 60, so I'm just going to set this one angle equal to 60. Seems like much easier math, smaller numbers, so I won't make mistakes like I did on 13. X is equal to 7. See how quick and easy that was? Like that. 14, jumping to 18. Yes, I cut some of these problems out. You're welcome. Select the true statements for the triangles below. Triangle PQR is congruent to... Okay, so these are just congruency statements, and you gotta go select the ones that are true. So, looking at these two triangles, you know that 1, 2, 3, 1, 1, 2, and 1, 2, 3, 1, 1, 2. So U, T, S, Q, R, P. Oh, P, not R, P. All right, so basically just match them up, right? So like Q is a 1, P is a 2, R is a 3. So this would be congruent to T is a 1, U is a 2, S is a 3, right? Like that's an option. We could rotate this, right? So this could just be P, R, Q equals, so now we're going 2, 3, 1. So 2, oops, I'm forgetting my triangle symbols, I'm sorry. Put my triangle symbols in there. Don't get lazy. U, S, T. All right, we could rotate it one more time if we wanted to. So triangle R, Q, P. And triangle S, T, U. So those are all fair. What if we did 1, 3, 2? Like, so we went the other direction, so to speak. So then we've got, what? Q, P, no, Q, R, P. All right, so that's slightly different. And then that would go T, S, R's with S, yes, U. Okay, and then you can rotate this through 3 times as well. All right, so then this would be R, P, Q. And S-U-T, and lastly P-Q-R with U-T-S. Okay, and I think that's actually all 6 possible congruency statements. Your key to this is as you scroll through these, you're looking to make sure that they match up. So you know that Q is congruent to T. You know that P is congruent to U, and you know that R is congruent to S. So they have to be in the same order. That's what you're looking for. As soon as they're not, so let's see, so like P and U, that's good. Q and T, that's good. R and S, that's good. P and S, oh, that won't work. So that first one would not be something you'd check, the second one would be, okay? So I think I probably spent too much time on this, but that's okay. Hopefully that makes sense. Now, once you do have a triangle congruency statement, it tells you 6 pieces of information. So we're going to use that to fill out all this missing stuff right here. So we know W, X, Y is congruent to triangle HJI. Really the only reason we want this picture is because it gives us the numbers, but otherwise all the information is already given to us right there. We know that JI is equal to XY, which is equal to 16. We know that, so that's A. We know that JH is equal to XW, which is 15. We know that measure angle W is equal to the measure angle H, and H is 37. We know J is equal to X, and X is 114. And we know that I is equal to Y. Uh-oh, both those are blanks. Now what? Well, you've got 2 there that add up to 151. So your remaining piece is 29. There you go, 29. Right, so that's just a triangle sum theorem. Add up your 3 angles, find your missing one. Select all that apply, triangle congruency. What's the methods to prove triangles are congruent? You could have side, side, side. All 3 sides are congruent. You could have side, angle, side. Okay, so this is all 3 sides are congruent. The difference here with side, angle, side versus angle, side, side, which can't work, right, is that you've got to have a side and a side with the angle in between them. So side, side with the angle in between them. That's your side, angle, side. If you have an angle on the outside, for example, something like this, this will not prove things are congruent unless it is a 90-degree angle. If it's a 90-degree angle, this becomes a right triangle. Pythagorean's theorem allows us to prove the third side is congruent, and we call this the hypotenuse leg theorem. Okay? Let's see. We can also do, if we have 2 angles with the side in between it, or 2 angles with the side anywhere. If you have any 2 angles in a side, you're in good shape. And that's because the third angle theorem will actually prove that third angle, so then you end up with angle, side, angle, because that's kind of the fundamental to all this. So if I have an angle and another angle and a side in between them, then we're in good shape. And even if that side length happens to be on the outside of them, again, we're in good shape because the third angle theorem would prove those congruent, and for the most part that creates another angle, side, angle, right? So there's that. Those are all the ones you want then. So those 5, 1, 2, 3, 4, and 5. That is not okay. Cannot do that one. Oh, and angle, angle, angle will also not work. And that's because I could do one triangle this size and one triangle that size. The reason why the angle side doesn't work is if I've got something like this, so I've got angle side, I could have the same angle with that side kind of rolled in on it, and I didn't draw this correctly, but there is a possibility to be able to do this where those side lengths are still the same and that one angle is intact. So that is why angle side does not work, and that's why angle does not work. All right, so there's your 5, the ones that are circled. 22, let's use them now. All right, so A, you've got angle, side, and another angle. So yes, by angle, side, angle. B, you've got side, and then down the middle, remember reflexive property. Even though it's not labeled, we know with 100% certainty that that is true. So this is side. C. Side. And there's not a third piece labeled, but we do know vertical angles are congruent with 100% certainty. We don't know if that's a 90-degree angle, so we cannot assume that, which means I have angle side. And again, we're not going to curse in math class, so throw that one out. This is not possible, or not enough information to determine. And then lastly, D, we've got right angle. So you're automatically thinking, as soon as you see right angles, you should start thinking hypotenuse leg. So I've got a leg and the hypotenuse. So this is yes by hypotenuse leg. Okay. All right. So that's 22. Proof time. All right. So with the proofs, you're not going to actually have to do them from scratch, but you are going to see the statements or the response or reasons, and you got to provide the other ones through a multiple choice kind of thing. So I'm going to show them a little bit from scratch, and then you can go fill them in later from your, I guess, recollection of what I'm doing over here. So we've got, oh, it's kind of a terrible drawing. Let's go back. It's a little bit better. Okay, so our given information is always how we start, right? So our first reason is always a given. Now, let's read it and make sure, but I'm telling you right now, 100% how you should be doing 2-column proofs if you're ever building them by scratch is you always start with a given. So, given, AC bisects BAD and BCD. What does that tell me? That tells me that this line down the middle cuts that angle in half. It cuts this angle in half. And so that's great news, and that's actually what number 2 and 3 are. This is going to be our definition of a bisector, right? It means it splits these into half. Definition of angle bisector. And I'm going to use that for 2 bisector. I'm going to use that for 2 and 3. And then I know that AC is congruent to itself because reflexive property. So that's 4, reflexive property. And then lastly, I now have an angle, a side, and an angle, side, and an angle. So these triangles must be congruent to each other by angle, side, angle. There it is. All right, so go ahead and fill those in. And I think the last one here for us is making the statements off the reasons. So let's kind of look the other direction. All right, so again, always starting with a given, just like we expected. In this case, we're looking at triangle WZX and triangle YZX are right triangles. There's our first statement. Okay. And then there's also a second piece of information there, which you'll see is the second reason as well. So they've done this into a second line, that segment WX is congruent to segment YX. This is actually kind of doctored up for you. That was nice. I probably should have deleted that. I'll make sure that's deleted on the test so I don't give away all the hints. So we know these are right triangles. We know that those are congruent with each other, WX and YX. And so what am I trying to find next? Well, I know that if I find another side here, we're in good shape because we have a right triangle, and then we'll have hypotenuse leg. So let's try to do that. There's our easiest, right down the pipe, because that's going to be the reflexive property. Sure enough, that's what the reason is reflexive property. And so we know that not xy, xz is congruent to xz, congruent to itself by our reflexive property. We now have hypotenuse leg, because we got a leg and a hypotenuse on a right triangle. So this will tell us that triangle, I'm going to go WZX is congruent to triangle YZX. Just make sure that we get corresponding parts lined up. And then if I know this triangle is congruent to itself, then I know all of its corresponding parts are congruent. And so based on that, we can make our final statement, which is what we're trying to prove. Angle WXZ is congruent to angle YXZ, and sure enough, we see it up there, by CPCTC, which stands for, CPCTC stands for corresponding parts of congruent triangles are congruent. In other words, once we know a triangle is congruent based on the 3 pieces of our triangle proof stuff we've been doing, the triangle congruency statements, then we know all 6 pieces are congruent, and we can make those statements like we did there. All right, pretty sure that's it. And it is. Awesome. Good luck on the review. You've got Monday, Tuesday to review. Test is on Wednesday. You've got this. Watch this video. Enjoy. Come in ready with questions, and we'll make sure you're feeling successful.